Hello, good evening, Satyajit sir. Am I audible to you?
Yeah, good evening. Hi, how are
Uh,
you?
Fine, sir. How are you?
Yeah, good. Yeah.
Sir, I'm the host for the today's session. My name is
Yeah.
Shweta.
Okay, Sweta, yeah.
Okay. Sir, we'll be starting in
So,
5 minutes. Okay.
yeah, actually I was just typing in, so okay. So if I got disconnected, na, just let me know because
Okay. Okay, sir. Sure.
that is one query from my side. So we'll start in another 5 minutes. Okay.
In another 5 minutes. Yes, sir. Sure.
Okay, fine.
Hello, good evening, everyone. Today's session is about classification in algorithm and logistic regression using Python, and Satyajit sir will be delivering this session. Thank you. Over to you, sir.
Yeah, okay, thank you. So let me start. So if anyone has any question, they can ask, and there is a chat box, so also you can type in, okay? So in between, if you have any question, you can ask. So let me share my screen. Is my screen visible?
Yes, sir.
Okay, thank you. Actually, I haven't used this WebEx frequently, so sometimes I feel a problem. So, okay. So hope I am audible, and today's topic is all about your classification. It's a more of an introduction to classification and logistic regression related with your ML machine learning algorithm. Okay. So coming to my screen is not moving. Okay. So now I think you might have seen this movie, Terminator. Uh, there are many, I think, maybe you can say the part of this Terminator. It was very old movie. So Terminator, I think if you come across this Terminator movie, so they have used a lot of, you can say, the robotics, you can say a lot of intelligence they have used. It's a more of a science fiction, but if you relate with this machine learning, artificial intelligence, you can easily relate with. So I'll explain you why I'm showing this screen is not visible. My screen is not visible.
Sir, your screen is visible.
Now it is visible now? Yeah, okay. So okay, fine. So I mean, if you can relate, if you have seen this movie Terminator, you can easily relate with the artificial intelligence, the robotics, and all. So the reason for showing this is there are three different types of intelligence. If I talk of this artificial intelligence, so there are three different types of artificial intelligence. So broadly, we can categorize it into ANI, AGI, and ASI. So artificial narrow intelligence, artificial general intelligence, and artificial super intelligence.
Hello,
Okay.
sir. Sorry to interrupt.
Yes.
Sir,
Yes.
your screen is visible, but the presentation is not visible.
My screen is visible, but my presentation now.
Not yet, sir.
1 minute. Let me. So, 1 minute. Stop sharing. Now, if it is visible, just confirm.
No, sir. Presentation is not visible. Only your screen is
Just,
visible.
just see. It will take time, I think. If it is now, it is visible. My first screen.
No, sir.
It's showing that you're sharing Windows Explorer. issue. Still not screen is showing. Now?
No, sir. Presentation is not visible.
Let me quickly log out and come back. Okay, 1 minute.
Yes, sir.
Okay. I'm just again sharing my screen. If it is visible, then just confirm. Now my screen visible.
Sir,
No, sir.
presentation is not visible.
Why today my presentation is not visible? I don't know. Now is it visible?
Yes, sir.
Yes, sir.
Now it is visible. 1 minute. Now?
Yes, sir. Yes, sir. Presentation is
Yes, sir.
visible.
Okay, fine. 1 minute. So now you can see only one screen. I mean, what is written in this screen here?
Three types of artificial intelligence.
Anything else? Showing anything
Yes,
else?
artificial narrow intelligence
Yeah,
ANI.
okay, fine. Only and any other windows are showing here in this
No,
screen or
sir.
not? Okay, fine. Then fine. 1 minute. Let me move again. Now it is showing one more screen.
Yes, sir. Artificial intelligence, machine learning, deep learning.
Okay, fine. Okay, so good. So let me explain this one. Sorry. Yeah. Your artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. Actually, a lot of time you might be, ask these questions because a lot of people will ask you in interview that right now, if you see the maturity of artificial intelligence where we are right now, we are still in artificial narrow intelligence. Whatever, let's say Alexa, chat box, anything that comes under your narrow intelligence. But we are slightly moving towards this general intelligence. And also the movie which I have shown you, this, I think that a movie that was, you can classify that one into super intelligence, artificial super intelligence. Okay. So right now, whatever happening in ML and DL, that will come under this narrow intelligence. But now as our computing power will increase, then you will move to artificial general intelligence. Okay. And obviously our target is to go for this artificial super intelligence, right? So now if we see, you might have seen, I think, this visual somewhere. The artificial intelligence is a bigger umbrella, you can say. Under that, the machine learning and then deep learning. Okay. There are three blocks. If you see clearly, artificial intelligence is a bigger umbrella. Then comes machine learning and then comes deep learning. Okay. So artificial intelligence, for example, we all have some kind of intelligence, right? For example, we talk of human intelligence, how to talk to a person, how to reply a person, right? If it is a sarcastic, questions, then how we can respond it. So that will come under a natural intelligence or human intelligence. But when it comes to machine to understand the logic, that will come under artificial intelligence. They are also able to respond your query, but in artificial way. They don't have that much depth. They can't understand more of a sarcasm, you can say. Machines are not that much, you can say, mature. They are not much trained enough that they can understand your sarcasm the way we people understand, right? So that is your artificial intelligence and natural intelligence. Then comes to machine learning, right? How we are going to teach machine to solve our problem, right? How we are teaching them, so that if you are giving them input and output to machine, then how they are going to give us an algorithm, how they are training themselves, so that if we apply some unseen data, that then they can predict it whether it's correct or not. So that is your machine learning, where we typically do feature extraction. Then that feature, once feature is extracted, then machine learning typically apply some kind of algorithm. They come up with some kind of, you can say, the equations, the input and output combinations. Okay. So that we call it a machine learning. The way we are teaching machine to learn, right? Then comes to deep learning. So in deep learning, if you see, if you compare machine learning with deep learning, the one fundamental difference of machine learning and deep learning is of the hidden layer. In deep learning, we'll come across hidden layer. The feature extraction and the classification or regression part happens in a single block. That is why input, output, and there is a one more block called DL algorithm. The feature extraction as well as classification, you can say, if you are applying a classification problem, then the feature extraction plus classification happens in a single block using the black box model. The black box, you can say, the hidden layer. So that is why it is called a deep learning, right? So now, if you see this one more, you can say, the visual, this one. So machine learning is divided into three parts. One is supervised, unsupervised, and reinforcement learning. Okay. So now I'll explain what is supervised, unsupervised little later. But here, if just I'm giving a hint. Supervised means you have some input and output combination, or you can say the features and target variable. In unsupervised, you only have input, or you can say you only have features with you. You don't have output combination corresponding to those input features. So that is unsupervised. So unsupervised, you might have heard of a technique called clustering. We are trying to make cluster if they have homogeneous distance. If they have a similar, you can say, features, then you make cluster out of that, right? So supervised, unsupervised are the two machine learning technique, and there is one more called reinforcement learning, right? So reinforcement means we try to learn from the mistakes. I'll explain you this reinforcement. But in supervised learning, classification and regression happens, right? But in unsupervised, you have two more techniques called clustering and association. You might have heard of you can say the application called market basket analysis. That is the application of association rule mining, right? So today we will talk of classification algorithm, right? So now this is extension of your previous slide. So in classification, we are trying to come up with two class. I'm talking about the binary classification. For example, if you want to give loan to particular person or not, the loan acceptance and loan denial. It's a two class problem. Maybe the customers are churning from, you can say, off from your firm, right? The customer churn and not churn is the two class that will come under binary classification problem. That is a supervised technique. Similar is with your regression technique. Regression means, for example, if you want to predict continuous outcome, that will come under regression. Then it comes to unsupervised learning, where I already told you, we'll come up with different clusters based on, you can say, the distance measure. There are different distance measure. For example, Euclidean distance, Manhattan distance. There are many distances. Based on those distance measures, we come up with different clusters. Then it comes to reinforcement learning. We are trying to reinforce the training, you can say, the learn, so that machine can learn. For example, you might have heard of this autonomous car, the Tesla's autonomous car. So they have three parts. One is environment, the model agent, and the state, right? So they try to understand the error, you can say, the based on the environment and model agent, and also the state. If there is some errors, so typically in reinforcement learning, as per my understanding, there is no such training data. They learn from the environment, they train themselves, and they continuously update from their mistakes through the feedback mechanism, right? So that will come under reinforcement learning, right? So if you see this one, this is quite interesting. You have already done this linear regression, multiple linear regression, right? So in those two regression, you can say simple linear regression and multiple linear regression. If you see the extreme left part, the supervised part, they were predicting your continuous, you can say, the numerical value, right? You were predicting a numerical value. So that will come under simple and multiple regression. Similarly, there is also more regression called ridge regression, lasso, Bayesian network, neural network, and quantum computing, right? Quantum computing is new one. Neural network will also give you a numerical value. The Bayesian network, lasso and ridge is for regularization. When you go for hyperparameter tuning, then you will understand this L1 and L2 regularization. Then comes to classification algorithm. So it is more of a categorical value. You are trying to predict category, the class, whether a customer gonna churn or not. That we are going to classify it. So that will come under your supervised learning, right? So there are different algorithm, you can say ML algorithm. First one is logistic one, which we are going to understand today. Then KNN, that is K nearest neighbor. Naive Bayes decision tree, ensemble trees, you can say the random forest, support vector machine, and neural network. So these we are gonna touch upon in coming, you can say, coming days. Then comes to clustering, K means clustering, hierarchical clustering, and the neural network. So if you see the neural network, it's under all three categories. So that is why it makes it more convenient for people to pick up neural network, because the accuracy is more higher, right? And also they use hidden layer. So that is why most of the, you can say, at enterprise level, you'll see people are training, this neural network, right? Due to the accuracy part, but it takes time. And also it takes lot of, you can say, the training data. But ultimate outcome is that it provides less error and more, you can say, there will be more confidence in using this neural network if you are able to explain the black box, right? So now today we're going to touch upon this logistic regression. It's one of the classification algorithm for binary classification, as well as you can use it for multiple classification as well. But I'll gonna explain only the binary classification. How you're going to predict the class level based on the training dataset. If you have a training dataset, and now if on the unseen data, how you're gonna predict the class level. So that will come under the logistic regression. It will use the log part to come up with the class level, the prediction of the class level. So before I explain this logistic regression, I just want to give you the the two case you can say, so that you can understand how you can apply those two. I mean, the problem in logistic regression. I'm not gonna uh, explain you here this logistic regression, but before that, I'm just explaining you how this business problem can be applied for formulating the logistic regression, right? So a doctor wants to predict the likelihood of successful treatment of a new patient, right? Based on different attributes, you can say the different attributes means different features, you can say, such as here we call it of attributes: blood pressure, hemoglobin level, sugar level. So name of the drug given to patient, name of the treatment given to patient, etc. These all are the, you can say, the attributes. Here the target variable would be the past cure status. So based on those, you can say the parameters, the attributes, blood pressure, you can say the sugar level, drug given, all these are, you can say, the features, the input variable, and whether the patient was cured or not. That is your target variable, right? So if patient got cured or not, that is a binary classification, right? So you can put a label yes and no. Okay. So this is one case where in the medical industry, this is one business problem, right? One of the problem you can say that can be addressed using logistic regression to predict if a new patient comes and people are able to, uh, take these blood pressures and all these all attributes. If they have all these attributes with them, they can easily predict whether that person could be cured or not based on your historical data, right? That's those trained data. So what benefit that could be get is the given the health profile of a patient and the, you can say, the recent treatments and drugs taken by him or a doctor can predict the probability of a cure and identify necessary changes to treatment, and also they can give the drug recommendations. So these some benefits could be get from this business problem. Okay, and this problem can be solved using the logistic regression because it's a classical case of a binary classification, because patient is gonna cured or not based on those 7 to 8 features will come under logistic regression. That's a classification problem, and one of the technique to solve is logistic regression. Okay. One more problem, just see this one. For example, a bank loan officer wants to predict if loan applicants will be a bank defaulter or no defaulter. Okay, non-defaulter. So it's a binary problem. The people gonna default or not default, right? So based on some attributes, for example, loan amount, monthly installments people are paying or not, where tenure of employment, how many times the applicant has been delinquent, annual income, debt to income ratio, etc. These all are the some, you can say, the attributes, and based on those attributes, let's say I have such 1 lakh of such customers, their historical data is with me, and I have also one column, a target column, where I have defaulters and non-defaulters list. Okay, so this will give us an idea. This will give us an idea, and this is a case of a binary classification problem. So target variable would be the past default status, and the predicted class would be include value, for example, yes or no. If people are defaulting, we will say it yes. If they are not, then you will put no. So when you encode it, yes will become 1 in Excel sheet and no will become a 0, right? For because ultimately we want to model it, right? So what business benefit will get this bank, right? Once classes are assigned, the banker will have a loan applicant data set of scheme. Each applicant labeled as likely or unlikely to default, right? So based on these labels, bank can easily make a decisions on whether to give a loan to such applicants or not. And the credit limit and the interest rates, you can say, So based on those, they can also reduce the risk. For example, if I'm able to understand that based on those historical data, if a new customer comes and he is asking for loan, so based on those trained model, I'll provide the, the unseen data, you can say the new customers data, I'll feed in, and I'll see what my model is saying. If my model is saying that he gonna default, obviously I'm not gonna provide the loan, right? So ultimately I'm able to save money. Obviously those money who that was, we are going to save some money, right? Because we are saving people, and also because people, if they are defaulting, it means they are taking money out of the bank, right? So there are many cases happened in India as well. You can recall the many, the big names, they defaulted. If they had such, a problem already, this, you can say, a trained model, they could have easily, prevented those defaulters, right? So these are the some benefits. Even if they are able to identify 10 such defaulters, if they are the huge money takers, then a bank can save millions of money, you can say, right? So that is why it's very important to understand the logic behind why people use, why enterprise level they use machine learning and deep learning, right? Ultimately we are solving a real life problem, a business problem, right? So if you see this data set, hope this is visible. So in this data set I was just showing you. So typically the bank, they capture age, gender, you can say the loan size, time payment was overdue or not, whether they defaulted or not. So these are the historical data. It's just only three data. But if you have lakhs of records, so this is how you can say the age, gender, loan size, times payment was overdue. These are the features. And the last column, default. This default was defaulted. The question mark defaulted is your target variable. Okay. So 4 input feature and 1 output, you can say. Okay. But in classification problem, we call it a feature and target combination. And the last one is a class. Also, we call it a class or target. And the labels are 0 and 1. Those who are not defaulting are being assigned by 0, and those who are defaulting is given a 1 here. Okay. So feature and target is the way we are going to model it for a classification problem. So age to times overdue is a feature, and last column is a target variable, okay, a class. So how logistic regression typically looks like. So if you see this visual, age, income, gender is a input, you can say, and output is a purchase. I mean, whether they purchased it or not. Based on these three features, we are able to predict yes and no. So whenever we are model this logistic regression, first, obviously we provide input and output to ML, I mean logistic regression model. This is, let's say, ML model. We are providing input, age, income, and gender. Right now we have only three, you can say, the features available with us. And output is yes and no. So this, when you apply this logistic regression model, this will give us some equation, you can say. And if there is a one more, you can say, unseen customer, so I'll provide age, income, and gender only to this equation, you can say, once a model is developed in that model, and that model will give us prediction whether you're gonna purchase or not. Okay. So this is a simple one. We have to provide input and output while training any ML model. And when we are testing it, we will only provide the features, because ultimately we are trying to predict it yes and no. So while training, we will provide input and output combination. And when we are predicting it, only this input feature of those customers which we want to predict. Okay. This is a simple case. Okay. Now, so now I'm just giving you a simple background of this simple linear regression, because you have already studied it. because you will get confused with logistic regression and obviously the simple linear regression. Okay. The simple linear regression is for predicting continuous output, you can say, but logistic regression is for binary, you can say, or multiple classification problem. But here we are talking about the binary classification, right? So that is for discrete output. Logistic regression is for discrete output, but simple linear regression is for continuous output, predicting a single continuous output. Okay. So this is a small difference. I'm just touching this simple linear regression so that you will not get confused. So in simple linear regression, for example, if you have one independent variable, for example, sales is one independent variable and revenue is a dependent variable. Okay. So dependent means it is depending on the sales. That is why we call it revenue as a dependent, because revenue is depending on number of sales. If number of sales will increase, obviously the revenue will increase, right? So sales and revenue, just think of independent is a sales and dependent is a revenue. And based on, let's say, 20 such, we have data points of 20 such customers. Okay. Now we have plotted it out, X and Y. So when you fit this regression line, this is called line of best fit. Okay. And these are some data. So this will predict it. This is called a residue or something. Okay. I'll explain you what is this. So once you model it, so this will give us a mathematical equation. This will give you a mathematical equation. For example, dependent variable here is revenue and independent variable is sales. And these all A, B, and U, you will get it from only the training data set, right? So these are the some coefficient, okay? And these are some intercept. So intercept is nothing but, if you see this one, anything cutting on y-axis is called intercept, okay? So this is intercept, okay? But there is something called residual, okay? Residual error. This is also called an error, U, okay? In simple linear regression, we have a dependent variable, that is revenue, equal to intercept plus slope. We will get it from the training data set, plus sales plus the error part, the residual error, you can say. So what is residual error? Anything which is away from this line of best fit is called residual. Okay, this one is residue. All are residual because all data points are away from this line of best fit. That is why every data points is residual. So number, you can count it, the number of this black dot, these all are residual, and their error is gonna minimize it. We just, the logic behind this simple linear regression is that we just want to minimize the error from this line of best fit. Okay, so let me explain you this. Okay, so for example, this we call it an intercept. So the data, these are the data points, blue one. Okay, these are the data points, and their distance from this line of best fit, we are just want to minimize it. That is why there is some square. Okay, because yi minus yi cap, this is actual one and this is a predicted one, and we make it a square. So we are trying to minimize the error. The logic behind any simple linear or multiple linear regression is to minimize this residual error, so that our prediction accuracy, the R square value is gonna higher, right? So the logic I already said in this simple linear regression is to minimize this residual error ultimately. Okay. So once you have a training data set, input output combination, you will apply, let's say, simple linear regression. And then this simple linear regression will give you some equations. This is a simple logic behind this simple linear regression. Okay. So it will give you some coefficients of the independent variable. These are the x is independent variable. So this will theta 1 is the coefficient of this independent variable, which will come from this training data set, because training data set will have some kind of a pattern. So based on these training data set, they gonna display equations. Why? Obviously, they have some pattern in the data set. So pattern obviously is going to translate into these equations in the form of, you can say, the coefficients. Okay. So every training data set will have certain patterns that can be modeled using these equations. Y equal to mx plus c, right? It's a line of a straight line equation of a straight line. Y equal to mx plus c. Okay. Now, this is the residual. Typically, we just want to, you can say, want to reduce it. Okay. So y equal to mx, this is mx, this is c. Okay. Ultimately, this is a line of equations, and this is called intercept, where any line which cut on the y-axis is the intercept. Okay. So intercept is from 0 to this one is the intercept, w naught. Okay. For x1, sometimes also we call it explanatory variable and response variable. Okay, don't get confused when you call it an independent or explanatory variable in regression. Okay, explanatory variable and response variable is the same thing. Sorry, explanatory variable and independent variable is the same thing. And response and target is same thing. Okay. So this was simple linear regression. You can easily recall in simple linear regression, we are trying to predict the continuous output. That is obviously, but in logistic regression, our struggle is to predict categorical class. That is the, you can say, the simple, a thin line difference between simple linear regression, multiple linear regression, and logistic regression. Logistic regression will fall under classification algorithm, but simple and multiple regression obviously will fall under regression technique. Okay? So now we will cover this supervised, unsupervised, labeled, remember what all these things are, right? Labeled, unlabeled. Sometime you might have heard of this labeled data set, unlabeled data set. Okay. So what is this? Okay. Decision boundary, what is cost functions in this logistic regression. Okay. These are the some important topic, right? So now, yeah, okay. If you have any question, you can ask. Otherwise, I'll continue. Okay. So no more question. Okay. So now coming to this supervised learning, right? Supervised means obviously any data set that will have some output and input combination. For example, we all are supervised once we are trained, right? So our final example, final exam, we can treat it as a, you can say, the test, and whatever we are learning in the semester from 3-4 months, whatever we are learning, that will come under the training part, right? So in supervised learning, we maps an input and output based on obviously input output pairs. So whenever you see any data set that has input and output, feature or target, explanatory variable and response variable, then you can easily figure out that this will come under supervised learning. Okay. So this is a simple, you can say, the definition of supervised learning, where you have a combination of, you can say, input and output. Okay. So that is your supervised learning. Okay. So now, if we see visually how supervised learning looks like, obviously, if we have some, you can say, the raw data, once we apply supervised learning technique, for example, where we are applying this logistic regression. Okay. So logistic regression will have some training and testing data. Okay. So training and testing data, and we are applying this algorithm, let's say, called a logistic regression, and this is our input data. If you see, they have a D class. Okay. Here in input data, right? So we will train it. For training, for example, if you have 100 uh, observations, so we typically use 80% of data for training and 20% for testing. Because obviously, for any training purpose, for example, even in semester, you can say for 6 month semesters, typically you are taught for 4 months, and exam is obviously for 2 hour durations, right? So majority of the time you are getting trained and you are test for for 2 hours, you can say 2 or 3 hours, right? So number of hours in the training are devoted more, but in testing case there is a less testing time is required. For example, if we have 100 data points, so we'll use 80% of data for training purpose and 20% for testing, so that our model will be more matured, there will be less error. If we are using, let's say, 50% of for training and 50% of testing, obviously we'll get more type 1 and type 2 error, less accuracy for that model. So that is why typically 80-20% is training and testing, and also sometimes 75% and 25%, depending on the industry, right? So once we apply this logistic regression on input data, they are classifying it into the three class levels. So logistic regression can be used for multiple classification as well as for binary classification. So in supervised, obviously input and output combination, and if it is a classification problem, then it will predict the class level, right? So similarly, if you see this labeled one, this one labeled one, apple and a strawberry. Now we are applying, let's say, logistic regression. The machine learning model is logistic regression, and the output we are getting is apple and a strawberry, right? So if we have some unseen data, let's say unseen example, so if you apply this unseen, you can say the data to this model, this is gonna give us whether it is apple or a strawberry. If we have only two kind of a class to predict, right? So in supervised, now we have an idea that input and output should be there. Input output pair should be there, right? For a supervised learning. So now what is labeled and unlabeled data? Okay. So when you are, for example, you might have seen a water bottle without any labels. Okay. There is a no label there is a no label on the water bottle. Labeling means there is some kind of, you can say, uh, input and output combinations. Based on those, they are putting some labels. For example, in this image, if you see on the right side, the cat, it is written cat below the picture of cat, dog, right? There are different cat and dogs, and their names are also written that this is a cat. They are identifying it, right? It's a cat and dog, right? But on the right side, if you see, this is unlabeled, only image is there, but it's not written what is that, cat or dog. They haven't written it. So this is unlabeled one. They are not labeling it whether it is a cat or dog based on certain features. Okay. If it is unlabeled one, it's very difficult in supervised learning technique, right? So ultimate struggle in machine learning is to put in label. This is the crux of machine learning, and you can say uh, AI/ML. In AI/ML, people struggle with this labeling. Once they are able to label the data, the next step is easy, right? So labeling is very much important. If you are able to label your training data set, you can do wonders. Okay? So now, in classification, obviously, it's a supervised learning approach that is used for categorizing, you can say, the classifying a given data points into two classes. I'm talking about this binary classification here. For example, whether the given mail is spam or not, right? So that is one of the classification problem that most of the, you can say, digital marketers get. Maybe even independent firms get, if they are getting lots of this spam mail, right? Predicting whether monsoon will be normal next year or not. It's a binary classification, right? So these are the some examples of classifications. For example, the online fraudulent transactions, whether it is a fraudulent transaction or not, right? If you are transferring money digitally, right? They have a tumor or not, the rain is gonna happen tomorrow or not. So if you are classifying in two class, so this will be the typical case of binary classification. Okay. And that is obviously a discrete one. When you are saying a binary classification, somehow we are approaching toward this discrete one, right? So in classification problem, obviously we are predicting this discrete class, right? So in logistic regression, it's a predictive, you can say, the algorithm techniques using independent variable to predict the dependent variable, just like you can say the linear regression, which I have already shown you. It's a similar one, but there is a difference that the dependent variable should be categorical variable. It's a bigger difference between simple linear and this logistic regression, right? So independent variable can be numeric or categorical variable. In case of logistic regression, if you see the features one, they are talking about the features. In whenever you talk of this independent variable, in case of logistic regression, we talk of the features variable. So features variable could be numeric or categorical one, but dependent variable must be categorical. It should not be continuous. If it is continuous, we have to apply simple linear or multiple linear regression. If you have a multiple, you can say attributes or features, right? So logistic regression is a statistical model that uses logistic function. It's very much important, right? Logistic function to model the conditional probability. I'll explain you what is this. Okay? So just remember this, logistic regression will use this log function to model, right? Your input and output. Just see. Because ultimately for binary classification problem, we have to give 0 and 1. Whether you can say that is the email is a spam or not. If it is a spam, then we put a label of 1. If it is not a spam, then we put a label of 0. So it will use a log function. This fz equal to 1 divided by 1 plus e to the power minus z. This is, you can say, the log function, right? So log is gonna convert any, you can say, the input to between 0 to 1. This is the feature of this log function. Because ultimately, whatever features we have, based on those features, we have to convert into 1 and 0. So obviously, all those features must be applied the log function so that it will be under 0 and 1. It cannot go beyond 1. Okay. So now this is a simple log function. So z equal to mx plus b. This is a typical model of logistic regression. Okay. And if you apply this fz here, right, f of z here, so it will model into a logistic regression model. Okay. So it is called sigmoid functions that expresses the value between 0 and 1. So obviously the use of this sigmoid function, that is, you can say, the logistic one, in logistic regression will convert the value, you can say, the output between 0 and 1. Okay. So that is why sigmoid function is used, because that is gonna express the value between 0 and 1. It cannot go beyond 0, it cannot go above 1. It will be under 0 and 1, right? So that is why sigmoid function is used. Okay, now just see this one. This is a interesting one. When the input can only be assigned to one of the two class label, it is called a binary classification problem. Just see. We have a two features x, or let's say for a loan prediction whether this person is gonna default or not. So obviously we had 3-4 features, but in real life you'll have more than 10 to 15 features. So the number of features will be the number of dimensions. You might have studied in this PCA principal component analysis. The number of features is the number of dimensions. If a person is given a loan based on 15 such features, so we can display 15 dimensions data, and based on those we are predicting the class. Okay, so assume 15 features are the 15 dimensions, and these are the two class. One is, let's say, loan given, and otherwise is loan not given. Okay, or defaulters or non-defaulters, you can say. Okay, so this is how we model it in a binary classification problem, the logistic regression one. This looks like this. Okay. So here it is written, if output is 0.5 and this one, I'll explain you this. What is this? Okay. So now there is something called decision boundary. Okay. In decision boundary, if you see this one, we are just classifying it into two class. So this one is a decision boundary here. We are deciding it if any points above this one will fall under this class. Let's say this is defaulter one, and any points you can say here falling will fall under this non-defaulters. Okay. So this is a decision boundary. Our ML algorithm gonna interpret this line, and if there is one unseen or target data falling under below, they're gonna classify it into non-defaulters. If it is falling under above this line, this decision boundary, they're gonna classify it into defaulters, right? So this is how decision boundary works in ML. This in logistic regression. Okay. So now decision boundary means obviously there will when you are going to apply this sigmoid function to the all input features to predict the class level whether it will fall under 0 or 1, in that case you will come across something called a threshold value. There will a point, when you apply the log function, log will give you 0.4, sometime it will give you 0.7. So how are you going to interpret those one, that it will fall under 1 or 0, where we going to place it in which class? So there is something called threshold. So typically in enterprise level, they treat it 0.5 as a threshold, right? If a value of those input features when you apply this sigmoid function comes at 0.4 less than 0.5, then we said we will straightforward put it into class 0. If it is more than 0.5, we put it into class 1, right? So this is how decision boundary and your threshold is going to work to classify the class labels based on the input features, right? So this is your decision boundary. You can say the decision boundary is this one. They are just classifying it with this, you can say the two class using this threshold value. And they are putting into this negative class and positive class. Okay. So this is how decision boundary works in logistic regression, right? This is extension of your previous one, decision boundary, and putting into two class, churn or not churn, defaulters, non-defaulter, you can say, right? If it is a dog or cat, they're going to classify it based on those image data, right? So linear decision boundary is the one, because logistic regression will come under linear, you can say it's a linear model. It's not a non-linear model. If anyone has studied this, maybe the decision tree or decision tree, they will come under non-linear, you can say, classification model. But here, logistic regression will come under linear decision, I can say the linear model. Why? Linear means they are using this straight line, it's a linear one, to separate these two classes, which we call it a decision boundary. That is why it is linear. Had it been a non-linear, this line would have been like this, something like this, non-linear. Any feature, not straight line, to predict the class level. Okay. So if anyone asks you logistic regression is a linear model or not, you're gonna say this is a linear model. Okay. Because they use this linear decision boundary to separate these two classes. Similarly, denied side and approved side using this linear boundary. Okay. So this I have used only to show you how logistic regression classify the class label based on this decision boundary, and this will come under linear, you can say the linear model. Simple linear regression, multiple linear regression, and this logistic regression are the example of linear, you can say the linear ML model. Okay, these all. So there is something called cost function. I think cost is something called residual error in simple linear as well as this logistic regression. You can say the error part is the cost function. And majority, you can say in when you are training any ML model or any deep learning model, we have to struggle with this cost function. Ultimate aim of our ML model training is to minimize this cost function, because ultimately we have to reduce the error so that our prediction accuracy will increase. So this is, you can say, the constant fight of any, you can say, the ML engineer, is to reduce these cost functions. There are many ways to reduce these cost functions. There is something called hyperparameter tuning. I think here you are not going to understand it, but just understand in logistic regression, it's an error part. In simple linear regression, it's the residual error, you can say, that is the cost functions, and ultimate aim is to reduce those cost functions. Okay. So now, if you see the difference between this logistic regression and this simple linear regression, okay, logistic regression versus simple linear regression, okay. So in logistic regression and simple linear regression, just see, we have this independent variable. Where is, yeah, this one. This is independent variable. Let's say sales is independent variable and revenue is dependent variable. If you see, this is a decision boundary. This is a straight line. Okay. So if we have a logistic regression problem, that could be solved using this linear regression as well, or multiple linear regression. But we need, for that, we will have to formulate many equations, and that is very difficult. So that is why logistic regression typically use sigmoid function, that is called S curve. So if you see, they are just squashing this line, is now squashing it into this only, right? 1 and 0, between 1 and 0. Now when I apply these sigmoid functions, it has become like a S curve, and now it is between 0 and 1. So R, obviously the purpose was to classify, right, into two class. So that is your, you can say, the logistic regression. Okay? So ultimate aim of this logistic regression is to bring down those predicted value between 0 and 1. But in regression, you can say linear regression, the ultimate aim or the prediction, you can say, the forecasting is for continuous output. Okay? That is why the value of this line is going above 1 and below 0, because they're gonna predict the continuous one. That is why it is being extended here. But in logistic regression, you are just seeing it is approaching towards 0 and it is approaching towards 1, and there is a threshold. It's not shown here, but of threshold of 0.5. Anything above 0.5 gonna fall under class 1. Anything below 0.5 is gonna fall under class 0, right? So this is a difference of simple linear and logistic regression. Okay. So if you see the data set of logistic regression, I have shown you the same data set here, right? If you see, now we want to see whether this is historical data, right? 1, 2, 3, you can say. The customer is gonna churn, oh sorry, you can say the employee is gonna churn from my company or not. And these tenure, age, address, I think 9 variable are independent variable. These are features. And we have now records, historical data with our company, that this person, those who have with this company for 11 years, age is 33, he is churning, right? And those 2 employees are not churning. These are the historical data. Now it's maybe we have thousands of record with the company, and now let's say there is one more employee. They just want to predict, right? Uh, whether a person who is with this company for 7 years now, age is 35. Now they have converted address into some continuous variable. Income is 80K, let's say, per month or maybe the year. And something employee, equip ID, caller ID, or something. These are the some features. And now this person is gonna leave our company or not. So this is a classical case of logistic regression. So based on those 3-4 records, first we will model our logistic regression. So logistic regression gonna give us some mathematical model, y equal to mx plus something, right? So now once that model is done, so now we will provide this input, only input to those ML model, right? This is the test data. It means this is unseen to the model. That is why sometimes we call it a unseen data or test data. Don't get confused if someone is using unseen data. Unseen means they are saying test data because that is unseen to the model. Model has only seen 0 to 3, up to 3. They have seen it. That is why they have modeled it into some mathematical equation using this output and input. But the model hasn't seen this record number 4. Now, once I apply this unseen data to that model will give us yes or no. A person is gonna churn or not, right? So this is unseen or test data. Now, this is simple one. Okay. So now if we have, let's say, equation called y equal to mx plus c. Okay, this is a linear regression, you can say here. For binary, you can say model. Once we apply this sigmoid function, this will change into this. So when we were applying this simple linear regression in logistic regression case, binary classification, once we apply these sigmoid functions, now our line of this decision boundary is gonna shift it like as. So this is, you can say, the sigmoid functions which we are going to apply so that our target value is gonna shift between 0 to 1. This will not gonna go above and below 0 and above 1. Okay, this is a typical case in logistic regression. This is mathematically, we just interpret it how mathematically this regression, logistic regression looks like when you apply, you can say the sigmoid function or log function to, you can say, the simple linear problem or classification problem. This will model us like this. Okay. So once you apply, once you have the value of b0 plus b1 plus x, this is a probability. This will give us value between 0 to 1. Okay, anything, let's say they have given 0.4. If it is 0.4, it will come under class 0. If it is 0.7, it will come under class 1. Okay. So logistic regression, as I already said, have some x is a input features, b is some biasness, you can say the error part, and w is weight, or you can say the coefficients. So this is a linear model. Typically linear, looks like a linear model, but once we apply these sigmoid functions, it will give us value between 0 to 1 depending on the threshold. If it is more than 0.5, we will say class 1, otherwise we will say class 0. Okay. So it's only the game of this sigmoid functions. Sigmoid functions play important role in this modeling this logistic regression. If you will not use this sigmoid function, it will clear case of this simple linear regression. Okay. So once we apply these sigmoid functions, they have modeled it into logistic regression case. Okay. This is a simple explanation of this logistic regression mathematically if you want to understand it. It's only the case of the sigmoid functions that makes simple linear regression problem, you can say, it's typically a simple linear regression, but they model it into logistic regression case once you apply these sigmoid functions, right? So as I already said, linear model, this is the equation of linear model. By applying these sigmoid functions, this straight line has become the S curve, right? So now let's say if we want to predict, whether this is a honeybee or not, right? So obviously if it is image, they're gonna convert these image into certain features, some numerical values, some values. Let's say these are the some features of this honeybee, right? And they are just summing it up. Now they are also applying this, you can say, sigmoid functions here, and now they are predicting it. Now here it is saying that the value is 0.83. Obviously if it is more than this threshold value, you're gonna say it a b or no b in two classes, right? So for image data also you can apply, right? Whether it is a bee or not, whether it is a cat or dog, binary classification problem. But how they do it? First they extract the features and they apply sigmoid functions, and then based on those predicted, you can say, the threshold value, they check whether we want to put it into class 1 or class 0. And we have the name of this class 1 and class 0, right? So this is a case of this logistic regression. Now, this is mathematically, I have already explained you. You can see how mathematically we can come up with this logistic regression, right? It's a simple formula, right? So nothing to worry about, but when to use logistic regression. So, okay. So when we're gonna use this logistic regression, that is more important for us, right? Because ultimately, when you see many problems, right? So we will get confused that when to use this logistic regression, right? There should be some hint, right? Otherwise, you will get confused because there are many ML and DL algorithms. But you must be precise enough that when to use this logistic regression, right? And once you know it, this is easy one. I won't say that you can't understand and can't figure out by looking at the data set. You can easily figure out if the output and the input combinations have in the Excel sheet. You can easily figure out if this is a binary classification problem. So we will use this different ML algorithm based on this binary classification. Just see, if our target data is binary, the simple hint is this. In that case, you will use one of the technique is logistic regression, because it's saying the target data, the target variable is binary. It should be binary. If it is binary in our Excel sheet or any data set we are given, if our target is binary, you're gonna use it this logistic regression. If you need probabilistic result, obviously probabilistic means they are saying 0 and 1. Either it is head or tail. That's a binary problem, right? Even if you need to get this probabilistic result, you're gonna use this logistic regression. When we need a linear decision boundary, when your question says that you have to use linear decision boundary, this is one hint which I am already told you that they're gonna use a straight line, a linear one. And logistic regression is a case of a linear you can say the linear model will fall under linear model because they are using linear decision model, right? So this is one of the, you can say, the hint. If you need to understand the impact of features, for example, if I want to know that for loan default case, if there are 15 features, so which feature is gonna impact the loan defaulters? Which are the important factors which which are driving towards the this loan, you can say, the default? So in that case, even if you want to understand the impact of those features, in that case you're going to use this logistic regression, right? So these are the some hints you must remember this one, so that you can straightforward can say that in this case, if you see any this case, you're gonna straightforward say that we're gonna use this logistic regression, right? So classification versus regression, as I already said, regression means you are predicting continuous output. For example, what will be the house prices be like in my town next year? It's a straight, the continuous output. Let's say this $208K. That is a typical case of regression. But in classification, you see the question, how question has changed, how they are asking you in different way. Will houses be affordable in my next year now, right? Affordable and non-affordable, right? Affordable and expensive, two classes. So whenever you see classes, you jump on to say this is a classification problem, right? But when you see the continuous output, you say it's a regression case. This is the first hint, right? So you see this classification regression, okay? So in regression and classification, just see supervised, both are supervised. But in classification, output should be categorical. Here in regression, it should be continuous. This is a simple, you can say, the difference between regression and classification, okay? And all these things, when you go in this, you can say, hyperparameter tuning, then you will understand this percentage of classification and all this. I'll explain you right today only. The percentage of correct classification, what is this type 1 and type 2 error, okay? And in this regression, you might struggle with this root mean squared error, R square value adjusted R square value and how much error associated with it, just to access, just to understand how your regression model is you can say fit for this regression analysis. Okay. So, but remember that in classification case, categorical, in the regression case, continuous. That's all. And both are supervised learning, right? This is a small case, so which let me discuss you. You can take snap of this screen so that you can read it out. So let's say I'm just explaining you this is small case so that you can understand. Let's say Zara is developing online clothing store. Some of their customers are already paying full price. Okay, let's say they have, obviously, in one of the retail store, they have, let's say, maybe thousands of customers, and in those thousand customers, let's say, many of them are paying full prices, but some are not paying the full prices, right? It's a binary classification. Just that is why full price and don't, I have just put it in the red one, so that you can understand this is a binary case. As a consultant to Zara, you are asked to create a promotional campaign, right? And offer discount codes to some customers. Your job is to provide these promotional, this discount, some of the discount to some of the customers based on this historical data that someone is paying full price and someone are not, right? In the hopes that this might increase the sales. Ultimate aim of any, obviously the outlet is to increase the sales, and the sales will drive to revenue, right? But the Jara don't want to send discount to customers which are likely to full price, right? Because they have a two type of a customer. One is paying full price and another is paying no full price, right? So, but Jara has a problem that they don't want to send it to every single customer. So how should you pick up the customers that will receive the discount? This is our small case, right? So how we gonna model it first? That is our case here, right? So now see, so obviously we want to send some discounts to some of the selected customers, right? So how we are gonna model this using logistic regression, and how we're gonna send some, you can say, the discount to those customers who are in need, right? So that ultimately we can increase the sales, because those who are paying full price, okay, fine, we are not gonna target those customers. But those who are paying, you can say, always looking for this discounted price, they come, not frequently. So at that time, we should give some discount so that revenue of this Jara can be increased, right? So now see, if you see on the right side, this is a data set. Also, you can capture this one. You can click snap of this data set, because ultimately I have to model it here. So if you see this one, amount spent, there are 9 customers, let's say, okay? And for this analysis purpose, I have used this small data set. So out of those 9 customers, there are two, you can say, one features which we have covered is amount spent, right? How much they are paying to Jara, right? From 1 to 9. And same discount in these are the some, you can say, the historical data. So a customer who was spending $50, you can say, they haven't sent discount. Those who were spending $10, $20, $5, they have sent discount, right? Based on historical data, if you see this one, right? Those who haven't spent a single penny, the last one, they have sent discount, right? So these are the historical data. Now we have to model it, and to whom we want to send discount, because right now they are not aware that how we're going to model it. And once the model is complete, then for you can say the test purpose for unseen customers, if they have only this, you can say, amount spent column, let's say if there is a 40 50, whether they're going to send it or not, because this is a small data set. Now you can easily understand the pattern. But had it been, let's say, the lakhs of data, you can't figure out that whom to send discount, right? That is why Jara is more interested in that for modeling, right? So now just see, I'm just using my R here. I'll use both. Just see this one. My screen is visible or not? Shweta, are you there?
Yes, sir.
Okay, fine.
Sir,
If
your
my screen,
presentation is not visible, only your screen is visible.
no, R is visible,
No, sir.
R
No,
studio.
no, sir. There is some
R
delay.
studio is not visible? Okay, no, R studio is not visible. One minute. Studio. Okay. Share. Screen share. Now my screen is visible or not?
Yes, sir. It is visible.
Now what is visible? Can you confirm? This is R studio is written. Some untitled this one. Is it visible now?
Yes, sir.
Okay, fine. So now just see. I think those who are not aware of this R studio just installed it. I'm just showing you because it will save some time, and also I'll show you one more example in Python. So don't worry. Okay. So just see the amount spent was this one. One of the feature was this. Okay. So just run it here in R. If you run it, this will look like this. So that is why I told you to just take snap of this table. The first customer spending was $50, $10 second, and so on. Okay, fine. Now I think you can easily associate with this uh, coding, right? And one more, this is amount spent is your input for your understanding. And here now send discount is output. This is a binary because 10 is written. Okay, fine. 0 means we haven't sent discount. 1 means we have sent discount to all these corresponding customers. This is a training data set. Okay. Now, just for our understanding, this logistic, this is user defined. You can use LMN, anything, ABCD here. This is user defined. But just see, this is called a GLM. GLM function is called generalized linear model. As I already said, logistic regression is a linear model. That is why GLM function is used. Anything under bracket is a function. We call it a function. That is why GLM is a function. Send send discount is output. Okay, send discount is output, and this tilde sign is a relationship. This is kind of a equal to your amount spent is the input. So input and output combination using tilde, this is a relationship sign, and this GLM function, this GLM function will use this sigmoid function as well. In this, they will apply this sigmoid function here so that the value can be between 0 and 1. Okay. So now we are gonna model it. Okay. So now there is one more command called summary logistic. Okay. If you apply this one, summary logistic, okay, just yeah, yeah. So if you see this one, summary logistic, once I applied this summary logistic, okay, this is summary is a function, summary is a function, and logistic which I'm taking from above command, right? So logistic, whatever there was in logistic, so in what was there in the logistic, GLM to up to this command is there. So this command is gonna process inside this summary function. So what summary is giving us? If you see this one, the star sign will give us the significance part. This is significance part. Means amount spending has impact on your sending discount. That is why this is a star mark. There, just understand. So a star mark will give you the label. I mean the significance means the value. If you see, as I already told you in the previous class, the value should be less than 0.05. That is why it is significant. It means it has a causal effect. Cause and okay, causal effect. Okay. So causal effect, one is causing and there is the effect of those cause. It means amount spending is has some cause on I think sending discount. That is why the value is significant here because the value is less than 0.05. Okay. So now this much, if you can understand it, this is I think good to go. And now if there is some, let's say, unseen customers, okay, one minute, if whether it works or not, this one, let me explain you what is this. Okay, so there is some, one minute, let me explain you what is that. Uh, so in regression, if you see in the logistic regression, the coefficient of amount spending is this minus 0.006282, and the intercept is this one. This is important. Just you want to click image for a reference. This is intercept that is cutting on y-axis, and the coefficient of this amount spending is this. This is two important one. Okay, I'll show you what is this. Okay, so now let me come back to my original screen. 1 minute. So 1 minute. Standing. Can you see my screen now? Is it visible? Shweta, it is visible?
No, sir.
Okay, 1 minute. Let me again. Um, our studio screen is visible?
Yes, sir.
Okay. So everyone just take snap, I mean click it photo in your mobile, so that if I'll ask you now, then you can easily relate with, because this coefficient is important, this one and this one. Just take a snap. Okay. So I'm just stopping it here. This is screen and showing you my PPT. So 1 minute, where is my PPT? My PPT is visible. Hope it is visible. Visible?
Yes, sir.
Okay, good. Okay, so our data set was amount spent. This was input, and sending discount was your output. Okay. So based on this input and output combination in R, I have modeled it. Okay. Now, what will be the equation of that model? Okay, just in our programming, we have done this much. Okay. So estimated, this is the coefficient one, estimated value. Always, this any regression in any ML technique, you will get estimated value. Not, they are not gonna give you this exact value. They give you some coefficient. This intercept means cutting on y-axis, and amount of spending is your coefficients. These are the two important stuff right here. And it is significant. It means there is a causal effect. Amount spending has effect on this sending discount, right? So now, if you see, if there is a one more customer, let's say, okay. So if there is a one more customer and he has spent only, let's say she has spent only $10. So should I send discount to that customer or not? If you, this is the equation, y equal to mx plus c, okay. So amount spending, just see, amount spending, their coefficient is 0.0060 minus of 0.0060 is a coefficient. Okay. So that is why I multiplied input with this coefficient. And this coefficient is coming from our training data set. The out 8, 9, whatever customer was there, I have modeled it. From those model, I am getting this estimated value, which is coefficient of this input amount spent. That is why I have multiplied amount spent with this coefficient. Okay. And what is the intercept? That is the plus value. Okay. So plus value is your intercept. That is why it is a plus value. So this is y. Sending discount is y. This is output, y equal to m x, x is amount spent, plus c. This is intercept. So y, sending discount is y equal to m, means this is coefficient of this input, and c is intercept on y. So this is our model of logistic regression. Now there is an unseen customer whose spending is $10. Now should I send discount to that customer or not? If I just put 10 here in amount spending, I am getting 0.75. It means it is more than threshold value. It means I should send discount. Okay, fine. Hope I'm able to explain you this. Okay. So this is how we model it, and based on those model, I'm able to send whether I want to send a discount to that person whose spending was $10 or not. So we are classifying it now. Our task has much easier, right? Because we have a model. This is a model. Obviously, the equation, and though based on those we are able to understand that if someone's spending is 10, if it is 100, then obviously it will reduce, so we will not send it. Okay, so this is how you can explain based on this logistic regression, and this is a classical case of classification. Okay, so linear and logistic, if you see in linear and logistic one, uh, the broad classification, target is interval, here target is discrete one, predicted values are means of the targeted value at a given value of the input variable. Solve regression problem, here solve classification problem, this logistic one. For example, if you see the example, what is the temperature? It means they are asking you the continuous value, target one. That is why it will fall under this linear regression. Will it rain or not? Will fall under binary classification. Obviously, it will have a logistic regression approach we have to apply. It uses this as curve, that is a sigmoid function, you can say, and this uses this straight line, right? Because they're going to predict the continuous output. So this is a typical difference between this, you can say, the linear regression and logistic regression. Okay, so now let me use my Python programming. Let me show you how you're gonna model it using Python. So just a minute. Python Jupyter notebook. One minute, let me project my screen. Uh, how we gonna model it into your, you can say, in Jupyter notebook in Python, right? You can also use Google Colab. Uh, so just see how we will model it using logistic regression. Where is logistic regression? Screen is visible. Hope screen is visible, right?
Yes, sir.
I'm just assuming it. Okay. So in logistic regression, just see. I'm just running it a small program. I'll share you also. Uh, just see this data set first. Data set is important. Just see this data set. See. How can I share you? Chat box is where. This one is chat box, right? Okay, so everyone just access that data set. Hope you can access it. So if you open that data set, just everyone just open that data set. Okay. So in that data set, if you see, so in that data set, once you click that, you will see these stuff: index, employed, bank balance, annual salary, defaulted. These all are some features, right? Index is, you can just don't use this index. It's just a number. So employed, a person is employed or not, whether they have bank balance or not, uh, are they getting this some annual salary or not, and whether they defaulted in history or not, means obviously for paying loan, right? So in this four, no one has defaulted, but if you see the data set, you will see some defaulted also in this link which I have shared you. Okay, so now there are some commands like import numpy as numpy. Those who haven't worked on this Python, I'm just explaining you for those, right? NP here just for this multi-dimensional array. Just to put all these things into array, we use this numpy and we say it a NP, right? Pandas as PD, we will use PD in reference. Pandas is used for importing dataset because we are importing this dataset from where? From this link. We are importing this data because this dataset is there in this link and we are importing it. That is why we are using these pandas. That is a PD, right? And matplotlib is just for plotting the graph for data visualization. You can say also to visualize the data. I'm not using any, you can say the plotting and all, but if anyone can use it, you can use this matplotlib.pyplot, right? This is a library and we will say extension as TLT, right? For here command and all, right? So importing the data set, let me run it, this one. First, when I run this command, this asterisk mark means it is still running. That is why this asterisk mark, right? So if asterisk mark is here, just wait. Now I'll run the second command because now I'm importing it. And my data set is hosted here. So this command dataset means this is a user defined. You can use dataset 1 2 3, also abcd here also. Okay, this is user defined. pd dot read csv, this is a function you will use the way it is used. Okay, now this command, once I run command 3 in 3, my dataset will look like this and this will give us the first 4 commands. When you use this head command, head function, along with this data set, this will give us first 5 commands, first 5 records from the data set, which is hosted here, right? So now, uh, hmm. so now in command 4, just see this, let me explain you. In command 4, this is X means input. As I already said, in logistic regression, there is a combination of input and output. We will provide input and output to the model. That is why X here is input. And what is input? Employed, this is the features, employed, bank balance and annual salary. Employed, bank balance and annual salary. The way it is written, you will use it. Okay? Because it is in the data set, that is why we have used data set here. Okay? This data set. Because my data set is here. Okay? So these are the called predictor variable, means input. 3 input: employed, bank balance, annual salary. Okay, and y is output. This is also user defined. Okay, defaulted is the output the way it is written. So now I have collected input and output from this data set for modeling purpose. Okay, so this is called a target variable or attribute. Okay, input predictor variable, x is a predictor variable here and y is a target variable. Now I am gonna run it, command 4. Now, as I already said, we will split the dataset into training and testing. So we are using this library called from sklearn dot model selection import train test. Okay, these are the class and libraries. Okay, we are saying x train, x test, y train and y test, means we are just converting x into x test and you can say x train, and y test into y output into both test and train both. And this function train test split is going to split the entire data set. 20% we are using for the testing and rest for training. It means we are using 80% for training and testing. For testing sample size is 0.2, means 20%. A random state means we can use any state here. Okay, so don't get confused with this. Only just see, we are splitting the training and testing data, and testing data we are using for testing data is 20%. Okay, now there is now let me run command 5. Okay, command 4 is still running. Okay, So now, if it is running, then fine. Okay. Now, in command 6, if you see, there is something called feature scaling. Why we typically use feature scaling? First, just see feature scaling, just understand why we typically do feature and then we are scale it. Feature means here my feature is up to this employed bank balance and annual salary. Just see the bank balance one 8754.36. This is the rupees. Annual salary 532339. Just see 4 5 digit, and this one is 4 digit. This is, let's say, 6 digit, and this is bank balance is 4 digit and another is 6 digit, and similarly. So the range is the difference. That is why you just want to scale it. We can say the standardize and normalize it so that the value should be between 0 and 1. Okay. So whenever you apply logistic regression, you have to apply this entire command so that once you done this feature scaling the value of this bank balance and annual salary, it means we are standardizing it and normalizing it. Value will be between 0 point something something, and the value will be 0 between 0 and 1 here. Okay, once you apply this feature scaling. So from sklearn pre-processing, we are pre-processing the data and this importing this standard scaler, this command. Okay, and this standard scaler is a function that is going to normalize it, and transforming means they are going to standardize it first and then they're going to normalize it. Normalize means they are going to bring it into the entire data set into a bell shaped curve. It means the value will be somewhere in the mean and the standard deviation. Okay, there will be some mean and a standard deviation. It will fall under, it will follow a normal curve, you can say, not a standard normal curve but a bell shaped curve. Okay, now we are just converting x train and x state, x test, and we are transforming both values so that the value will be between 0 to 1. Okay? Now this is a creating a model, means we are fitting the, you can say, before that we are just creating a logistic regression model. So we will use from sklearn.linear model. Just see this word, because logistic regression is linear model. That is why this command is used from sklearn dot this linear model. Okay, and we are importing from everything. We are importing these libraries from this here. Okay, so now this model command equal to logistic regression. Now we are modeling it. So this is a simple command. Model means this, we can, this is user defined. We can use it like model 1 2 3, anything we can put it here. But logistic regression, the way it is written, you should use it because this is a function here. Logistic regression here, this is a function, and whatever there in logistic regression function, we are just putting it into model. Okay, and now we are fitting this logistic regression model. So model dot fit function and putting x train and y train. Okay, because we are training the model. Right now we are not testing it. We are fitting means we are making an logistic regression model where we are using this training data set x train and y train, because ultimately for model building we use training data set first. Okay, so for fitting the model we are using this fit command here and providing two you can say parameters x train and y train, passing the two parameters. So once you, I think we have run this command or not. First, fifth is run, sixth, seventh, eighth. Okay. So logistic regression, the way output will give us, and now we are predicting it using the test data. You are not using the training data here. We are using the test data, that is a 25%. Okay. Once we run this one, okay, we get something like this in the error format. It means 000 something something. It means it is giving us whether defaulted or not. It's very difficult to understand it. What is this? But now, once you run this confusion matrix, okay, it means this is 1920 23. What is this? 6 and 51. We are also not sure that what is this. Okay. So again, there is one more command here. This one, just see. So once I run this command number 12, okay. So here it is saying predicted is no, and actual was no. The person who wasn't defaulted, okay, and our also model predicted no is 1920. It means our model is this is not a problem. This is a good one. Our model also said that 1920 people is not gonna default, and in testing phase also we are seeing our model is also saying that okay fine 1920 is not gonna default. So this is a correct prediction. This 23 is also a correct prediction because our model is saying also yes and predicted yes also that 23 people is gonna default. Okay, fine from the model. So this is not a case. Problem is this one 51 and 6. Our model is predicted that they are gonna default, but actually they haven't defaulted. So this is not a problem 6-1. But the problem is this 51. Our model predicted that they are not going to default, but actually they defaulted. So 51 customers is like a problematic for us. Okay. So that is why this is a problem for us. Okay. So 51, this is a type 1 error. So you cannot, as a banker, you can say you can't, ignore these 51 customers because actually they are going to default it. But our model is predicting no. Okay, this is a error, type 1 error. This is type 2 error here. So in depending on the industry to industry, whether we have to reduce type 1 or type 2, but majority of the time we have to reduce type 1 error. Okay. So how you're gonna reduce it? We will use this. There is something called hyperparameter tuning, which will come little later. Okay. But just understand this type 1 error because 51 people are culprit and we are just, we are setting them free. It's like same case. Okay. So this is a problematic for this company, right? So now the accuracy of this model, if you see the accuracy of the model is 97%, it means our model is explaining 97% variance in the data, right? It means it's a good model, but still the 51 is the problematic, right? So this is how we typically model logistic regression. And also it's not about the modeling the any business problem, also understand the problem behind what is the problem and how we can come up with the solution. That is the main problem. If there is a type 1 error, then how you gonna solve it? Because 51 people is gonna default, we know it, but knowingly or unknowingly we are providing loan to them. That is much problematic, a bigger problem. How to solve it? We can solve it using this hyperparameter. Okay, because ultimately we have to reduce this type 1 error. Okay, so this is how we model it. If anyone has any question in this logistic regression model in this Python programming, they can ask. Okay, sir, what is difference between 1 minute? Where is your question? Uh, Someone has written a question. Okay, so what is random state? Okay, so random state means there is a state of you can say any data set. So this will come under random state, but once I teach you this hyperparameter tuning, because in that there is also some state. So in that case, you will understand, but also just remove the state, it will work. Okay. So second question is, sir, what is difference between fit and fit transform function? Can we please explain? Okay, fit transform function means we are transforming it. It means we are standardizing it and also normalizing it. That is a fit transform. Okay, it means it will follow a bell-shaped curve. Your every single feature will follow bell-shaped curve if you put this fit transform function. But fit is just fitting a ML model. Just for example, fit logistic regression. It fitting X train comma Y train. It means I am passing training data set to build a ML model. Whenever you want to build a ML model, we use this fit function. That is a difference. I think hope I'm able to answer you. Any question you can ask in the chat box, or you can mute yourself and unmute you, and you can ask. Any question now? Sweta, are you there? Shweta, are you there?
Yes, sir. Yes, sir.
Okay, anyone, any question you can ask. Otherwise, from my side, it is done. Okay. Okay, Shweta, from my side,
Any
it is done.
question, anyone? You may put your question in the chat box.
Someone has put in 1 minute.
Uh, Sir, there is one question. What is
Yes,
the
please.
difference between fit and fit transform function?
I have already answered it. So, okay, sir, fourth command y equal to defaulted. So, are we all target variable represented by it on all? Can this Priya can you speak? I mean, fourth, okay, fine. Y equal to defaulted. So, are all target variable represented by it? Yes, it is but here there will be only one target variable. This defaulted. So in binary classification or any multiple classification problem,
Hello, am I audible, sir?
yes, yes. Yeah, you are audible. 1 minute. So yeah, so I am just answering to Priya's question. So she just told me
Hello, sir,
that
are you there?
yes, yes, I am here, Sweta. Am I audible now? Let me ask you, am I audible or not? Am I audible or not? Okay. So hope I'm just assuming that I am audible. I'm just answering you
Yeah, you're
that fourth
audible.
command. Yeah. So I'm just answering you the fourth command that, yeah, defaulted one. Yes, you can use it the way it is written and represented by it. So all our target variable. Hope I'm able to understand your question. So the way I have represented it, you have to represent it like that. Defaulted. The way it is written. It should not be like anything you can write. The way it is written in your data set, you can write it. And the way it is written like parenthesis and all, you have to write it like this. Okay? Also, there is also different way. Minus sign.
Hello, Satyajit, sir, are you there?
Notebook. Yeah, yeah, I will confirm you. So, Sweta, are you there?
Yes, sir, yes, sir. Now you're audible to me. I think there is some issue at my end.
Yeah, yeah, you're in. Okay, fine. So now I'm able to answer you every. So just confirm me one thing. There is one Google Drive. Do you have access to that Google Drive?
Yes, sir, I have.
So I have uploaded my PPT. So all have seen my PPT there or not? My PPT is and programming was there in that Google
Okay.
Drive.
Okay,
So
sir,
just
okay.
check that. Just check that. And today's this logistic regression part, I'll share you this PPT and code as well. And just data set is also in the internet, so you can easily fetch that. Yeah. Mm, okay. So thank you so much. I'm just closing the session here. So Sweta, if you have any question, you can ask.
No, sir, thank you so much for this great session, sir.
Thank you. And if you have any question, just ask me in the next class or you feel like. Okay. So I'm just stopping it. I'm exiting from the one. Where to stop? Yeah. Okay. Thank you. Thank you, everyone. Okay. I'm just logging out. Thank you.